Imagine a world wrapped in darkness after sunset, where night silences entire cities, where no switch waits on the wall to answer human command, where communication moves only as fast as a horse can run, and work ends the moment the sun disappears beyond the horizon. A world where storms inspire fear instead of power, and lightning is seen not as energy, but as divine anger tearing through the sky. And in this ancient darkness, the story of electricity truly begins, not as an invention, but as a mystery, because electricity was never something humanity created from nothing. It was something humanity slowly learned to understand, observe, control, and finally command. And to ask who invented electricity is to ask who taught humanity how to steal fire from the gods without being burned. Because long before wires, generators, or power plants existed, early civilizations noticed strange forces in nature, sparks that jumped between objects, shocks felt when touching certain fish, and invisible attractions that defied explanation. And as far back as ancient Greece, people discovered that rubbing amber with fur caused it to attract feathers and dust, a phenomenon so strange that it felt supernatural. And although they did not understand electrons or electric charge, they unknowingly witnessed static electricity, the earliest human encounter with a force that would one day power the modern world. And for centuries, electricity remained a curiosity, a trick of nature observed, but never mastered, discussed by philosophers, feared by ordinary people, and misunderstood by nearly everyone, until human curiosity refused to accept mystery as an answer, and the slow march toward understanding began, reaching a dramatic turning point in the 18th century when scientists across Europe started experimenting with electricity as a measurable force rather than a magical one. And among them stood a man whose name would forever be tied to lightning itself, Benjamin Franklin, who in 1752 dared to test a terrifying idea during a thunderstorm, flying a kite with a metal key attached to its string, not to invite danger, but to prove a revolutionary theory. That lightning was not divine punishment, but a form of electricity, and when sparks jumped from the key to his hand, Franklin did not just confirm a hypothesis, he shattered centuries of superstition, proving that the same force seen in tiny laboratory sparks existed in the violent storms of the sky. And with that realization, electricity moved from myth into science, becoming something humans could study, measure, and eventually control. And yet understanding electricity did not mean using it, because knowing a force exists is very different from knowing how to harness it. And the next great leap came from a quiet bookbinder's apprentice turned scientist named Michael Faraday, a man with little formal education, but an unmatched ability to see patterns where others saw chaos. And in the early 19th century, Faraday made one of the most important discoveries in human history when he realized that electricity and magnetism were not separate forces, but two sides of the same phenomenon. And through painstaking experiments, he demonstrated electromagnetic induction, proving that a moving magnetic field could generate electric current, a discovery that quietly laid the foundation for every electric generator on Earth. Because without Faraday, there would be no power stations, no turbines, no large-scale electricity production. And although Faraday himself never became wealthy or famous in the way others would, his work transformed electricity from a laboratory curiosity into something that could be produced endlessly. And still the world struggled with how to distribute this power, how to send electricity over long distances without losing it, how to make it safe, reliable, and practical for daily life. And this struggle set the stage for one of the most intense rivalries in technological history, the battle between direct current and alternating current, a conflict embodied by two very different men. On one side, Thomas Edison, a brilliant entrepreneur who believed electricity should flow in one direction through direct current systems. And on the other, Nikola Tesla, a visionary genius who imagined electricity flowing back and forth as alternating current, allowing it to travel vast distances efficiently. And this clash was not merely scientific, it was philosophical, commercial, and deeply personal, as Edison fought to protect his investments while Tesla fought for what he believed was the future of humanity. And although Edison succeeded in bringing electric light to homes and cities, illuminating streets and transforming night into day, it was Tesla's alternating current system that ultimately won the war, becoming the backbone of modern electrical grids around the world, enabling power plants to supply electricity to entire nations rather than just a few city blocks. And through this victory, electricity finally escaped the laboratory and entered everyday life, powering factories, homes, hospitals, and transportation, reshaping society at every level, extending working hours, accelerating communication, transforming medicine, and redefining what it meant to be human in a connected world. And yet, even then, electricity was not fully understood, as scientists continued uncovering the deeper laws of electrons, fields, and energy, revealing that electricity was not just a tool, but a fundamental part of the universe itself, woven into the structure of matter. And when we ask who invented electricity, the most honest answer is both simple and profound. No one invented electricity because it always existed, flowing through storms, atoms, and living beings long before humanity learned its name. But humans invented the knowledge, the systems, and the courage required to harness it. And that invention was not the work of one mind or one moment, but a chain of discoveries stretching across centuries, from ancient observers of static sparks, to Franklin's fearless experiments, to Faraday's invisible fields, to Edison's glowing filaments, and Tesla's dreams of limitless power, each adding a piece to a puzzle larger than any individual. And today, in a world powered by electricity, where screens glow in our hands, cities pulse with light, data travels at the speed of electrons, and entire civilizations depend on unseen currents flowing silently beneath streets and oceans, it is easy to forget how fragile this knowledge once was and how dangerous the path toward it had been. And as we flip a switch without thought, electricity answers instantly, a silent servant born from centuries of curiosity, risk, and imagination, reminding us that humanity's greatest inventions are often not things we create, but forces we learn to understand, respect, and guide. And so the story of electricity is not just about power, wires, or light. It is the story of humanity stepping out of darkness, daring to question the sky, daring to touch the storm, and finally learning how to turn nature's raw fury into the energy that lights our nights, drives our machines, connects our minds, and carries our future forward, glowing endlessly through the modern world like captured lightning, forever changing what it means to be alive in an electrified age.